Hello 7th graders and welcome to the 5.1 notes. Chapter 5 is going to be on proportions and percents. Before we get into percents as proportions, there's a couple skills we need to review. First off, percents and decimals. How do you make a percent a decimal? When we have a percent, it's out of 100, so we can divide that number by 100 or move the decimal 2 places to the left. For example, 147% is the same thing as 1.47. All right, so if we were to write 22% as a decimal, move a decimal place 2 spaces to the left, and we have 0.22. The second one, we would have 0.75. All right, pause the video, see if you can do 3 and 4 by yourself. Play it back to see if you got it right. All right, 3 is 0.06. 6%, when you move it another decimal place, you have to add a 0 in. And then number 4 is 1.89. All right, so let's go the other way now to write a decimal as a percent. Take the decimal place, move it 2 places to the right, or you can multiply by 100. So 0.59 times 100 is 59%. Pause the video, do 6, 7, and 8 on your own. Play it back to see if you got it right. All right, when we find the percent of a number, we have to remember that this word of in math is going to be multiplying. So when we do 50% of 64, we're doing 50% times 64. And if we're typing this into a calculator, we're going to have to use a decimal. So we're going to enter this as 0.5 or 0.50 times 64. When you type that in, you should get 32. All right, so number 10, we would type in 0.07 times 30, which is 2.1. All right, pause the video, try the rest of these by yourself, play it back to see if you got them right. Before we begin the 5.1 notes, there's some important vocabulary words we need to review first. We are going to match the checked words in the word bank with the section of the triangle. All right, so the first section says a statement that 2 ratios are equivalent. This is what we were working with in chapter 4. This would be a proportion. Proportion is a statement that 2 ratios are equivalent. The next section says it compares a number to 100. Well, a ratio out of 100, that's going to be a percent. And then a comparison of 2 numbers by division, that is a ratio. Also looks like a fraction. All right, so let's complete these sentences using the preview words, which are these words at the bottom box. So we have percent decrease, percent increase, principal, and simple interest. All right, a fixed percent of the principal is the simple interest. We are going to be solving for that in 5.3. The original amount of money deposited or borrowed is the principal amount. What we start with is the principal. All right, and a blank is the amount of increase divided by the original amount. That's going to be a percent increase. Percent increase. So if the percent increase is the amount of increase divided by the original amount, a percent decrease would be the amount of decrease divided by the original amount. All right, so in 5.1, we're going to be learning about percent increase and decrease. So to find the percent increase, we're going to look for the percent change, which is the amount of change over the original amount. Remember, another word for that original amount is the principal. So how much it changes divided by how much we started with. Percent increase is going to be when it's positive. A decrease will be when the amount goes down. All right, so example 1. Amber got a raise and her hourly wage increased from $8 to $9.50. What is the percent increase? Well, we're going to look back to that definition. We're going to look at the amount of change divided by the original amount. The original amount was 8. To find the amount of change, we need to take what she's earning now and subtract from what she started with. So 9.5 minus 8 is going to be 1.5. The amount of change was 1.5. Now to find the percent change, we put that into a ratio. So 1.5 over 8, do that division, and it's going to be 0.1875. We could either write this as 18.75%, or we could round to 19%. So her hourly wage increased by 19%. Let's reflect on this a little bit. What does a 100% increase mean? Well, if we look at the amount of change over the original amount, if that was 100%, that would mean that it doubled. It changed by what you started at. So it doubled. All right, your turn. Pause the video, try number 2 on your own, play it back to see if you got it right. All right, I'm gonna go ahead and solve it. So price of pair of shoes increases from $52 to $64. 64 minus 52, it changed by 12. To find the percent increase, I do the amount it changed over the original. It started at 52. 12 divided by 52 is about 0.23, which we're going to say is 23%. All right, so next we have percent decrease. A percent decrease describes how much a quantity decreases or goes down compared to the original amount. So let's look at an example. David moved from a house that is 89 miles away from his workplace to a house that is 51 miles away from his workplace. What is the percent decrease in the distance from his home to his workplace? Just like when we did percent increase, we're going to find the change over the original amount. So to find the change, we have to subtract what it is now in the original. So right now, it was 89, now it's 51. 89 minus 51, 38. So the change was 38. So we're going to put 38 over, he started at 89. So 38 divided by 89 is about 0.427, which we're going to round to 43%. All right, so if David considered moving even closer to his workplace, claims that if he had done so, the percent of decrease would have been more than 100%. Is David correct? Well, let's think back to the last page when we reflected and thought, what would a 100% increase be? That would be if it doubled. And then let's think of how the percent decrease is set up. Change over original. To be 100%, the change and the original would have to be the same. So if he started 89 miles away, it would have to also change by 89 miles. And unless you're considering directions, he can't travel a negative distance to work. So in this case, you can't have more than 100% decrease. David is incorrect. All right, so let's do number 4 together, and then you'll do number 5 on your own. So the number of students in a chess club decreased from 18 to 12. What is the percent decrease? Round to the nearest percent. Well, first we need to find the change. So 18 minus 12 is 6, and then we do change over original. So 6 divided by 18 is going to be 1/3, or 0.3 repeating, which is about 33%. All right, pause the video, try number 5 on your own, play it back to see if you got it right. All right, next we're going to use percent of change and think backwards. So let's look at this example. The grizzly bear population in Yellowstone National Park in 1970 was about 270. Over the next 35 years, it increased by about 115%. What was the population in 2005? All right, so first we're going to find the amount of change. We know the percent change, and we know what it started at, but we don't know the amount that it changed by. So we're going to do 1.15, which is 115% as a decimal, times 270, what it started at, which is 310.5. So it changed by 310.5. Now we need to find the new amount. To find the new amount, we're going to take the original, which was 270, plus the amount that it changed by. So original plus amount of change, 270, plus 311 is 581 bears. So the population in 2005 was about 581 grizzly bears. All right, let's reflect on this. Why will the percent of change always be represented by a positive number? Well, percent change is kind of like distance. So when we think absolute value, we think distance, and that's always positive. So the percent of change, whether it increased or decreased, it's a distance thing, it's gonna be positive. All right, try numbers 8 and 9 on your own, and then play the video to see if you got it right. So go ahead and pause it, and then play it back. All right, your homework today is going to be numbers 1 through 19 odd. So remember, this means every other number: 1, 3, 5, 7, 9, 11, 13, 15, 17, 19.